All right, today we're going to be looking at section 2.4. This is infinite limits, and there are two parts. So if you go through and read, we're going to be looking at infinite limits and limits at infinity. So one is as we approach a finite number. So let's just say we're going toward x. This graph is increasing without bound, and we would call this an infinite limit. It doesn't exist, so we don't have a value, so we say it approaches infinity, or the y value goes to infinity, the f of x goes to infinity as x goes towards 0. And on the other hand, if we were going the opposite direction, we could say as x goes to negative infinity, or as x goes to positive infinity, the y value would be approaching 0. So that would be limit at infinity. So let me make sure I said that right. Yeah, infinite limits just go to infinity, and a limit at infinity means as we're going to infinity, the limit might actually approach a value. So you got some different visuals here that kind of show you in the table format and in the graph what those look like. They explain how to read them and the mathematical definition. So here we go with the infinite limit. Again, they let you know that f is defined for all x near a, maybe not at a, but as we get close, if the f of x grows without bound or decreases without bound, because you got two different ones, then we say limit of f of x as x approaches a is equal to infinity, or vice versa, negative infinity. And then you can kind of see different graphs and how to analyze it analytically. So this is just showing a two-sided limit. Same thing works if we're doing a one-sided limit. So this is f is defined for all x near a where x is greater than a. So this means we're larger than the number, and we're decreasing, going toward the number from right to left. So that's what this image is showing you. It's getting close to this number a, and the graph is increasing without bound. Similarly, if you're getting close to some number and you're decreasing without bound, we just go to negative infinity. So they do a great job trying to show you visuals of that. The number that it is approaching is what we refer to as a vertical asymptote. That happens whenever we lose a factor in the denominator, or whatever sets the denominator equal to 0, I should say. Losing a factor will make a whole, and we'll show you some of those. But if you have some number that makes the denominator 0, that will be a vertical asymptote. And you see several examples here, and they're going through and kind of spelling it out, how that's caused, and still how to find it analytically. So they give you another example. If we were to approach this function going to 0 and we plugged in 0, we would get 0 on the denominator. That would be a vertical asymptote because it makes the denominator 0. However, if we just slowly inch closer to that number, we can see the overall y value increasing, 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 going toward infinity as this number is positive and going down toward 0. And here you get just a little bit more explanation and visual of what's going on. So you can also just start with a polynomial rational expression, and we can factor out and divide out terms. And once you factor out, again, if you were to plug in -4, it would give you 0, and on the top it gives you 42. However, if we look at the overall value as we're approaching that number from the right, this number would be positive, but as we got closer to -4, it would be a negative number on the bottom. So they're saying it's negative and approaching 0. The overall value of this is approaching 0. The numerator, once you plug in -4, gives you a positive 42. So you have a positive number over a negative number, which is getting smaller, so it's going toward infinity, but it will be negative infinity. And so the textbook is, again, trying to explain the limit going to infinity and then how to solve them algebraically. And then we get to, so let me go back. This is one of those where This one, when they did the polynomial function, they factored out and then they lose a factor of x minus 1. So I do want to talk about that. So when that factor cancels out, you have to remember we cannot use positive 1. That makes the denominator 0. The fact that it cancels out means we're going to have a hole in the graph. So it's no longer a vertical asymptote, it'll be a hole. And then as you plug in 1, you can still get a limit, even though it doesn't exist. You can know what the graph is tending toward. And so that's what it shows you on the next page. When you do it graphically, you have a vertical line that's an asymptote. Usually we represent that with a dotted line. At 1, you can kind of see this graph has a hole. That's the factor that canceled out when we factored and simplified the polynomial. And then we also at the very end talk about limits for trigonometric functions. Just remember that cotangent is equal to cosine over sine. You can kind of look at each of those values as they approach 0. And in this example, they'll let you know that the limit of cotangent as theta goes to 0 from the right is equal to positive infinity. And you can still apply the same techniques with trig functions as well. So with that, that's pretty much just a general overview. We're going to jump into my math lab and solve a few problems.